Hello everyone, Gaza Mutkarsh and I welcome you all to this session on NumPy for numerical calculations. So guys, let's have a look at the agenda for this session. So guys, the agenda for this session includes array combining functions, and the next we are going to discuss array insert and append function. We are also going to discuss the different matrix operations that we have for NumPy arrays, and we should also be discussing broadcasting. Now in previous sessions so far we have discussed NumPy arrays versus list, how to create NumPy arrays. We have also discussed NumPy array indexing, slicing and reshaping, and we have also covered different array functions. So guys, let's switch to the Jupyter screen. So guys, over here we are into Jupyter screen. So the first step is to import the NumPy as NP. Now to combine arrays in let's say NumPy, we do have different functions. We have concatenate, we have vstack, and then we have hstack. Concatenate can be used to combine arrays horizontally and even vertically, alright, for 1D and 2D arrays both. Now, as far as vstack and hstack are concerned, they are used to combine arrays vertically and horizontally, both for 1D and the 2D arrays. So guys, let's understand how each of these functions work and how to utilize them, let's say along rows and along columns, based on the access if required, and for both 1D and 2D cases. So the first function that we are going to discuss is np.concatenate, right? So np.concatenate basically, let's say concatenate function essentially joins a sequence of arrays along an existing axis. All right. So it will simply join a sequence of arrays along an existing axis. Let's consider this example. So the first array that we are considering is W1 that contains the elements 12, 13, 14, 15. The second array that we are considering is W2 consisting of the elements 18, 19, 20 and 21. So over here I'm printing W1 and W2. And clearly we can observe the shape of W1 and W2 are entirely same. So if I were to concatenate them, how would I write? np.concatenate, and inside the concatenate function, inside the list, we have to pass W1 and W2. By default, if we don't pass an access, the default access utilized over here is 0. How do we know? We can check this. So over here it says concatenate. I can concatenate A1, A2, n number of arrays, and along the axis 0. All right, and so this is the default. So join a sequence of arrays along an existing axis. So clearly we can see the default axis is 0. So in the axis we have to mention the axis along which the let's say arrays will be joined. So if the axis is none, arrays will be flattened before use. So how do we know the default axis is 0? We have just checked and validated. Now, so if I pass it like this, see 12, 13, 14, 15, and then we have 18, 19, 20, 21. Now, what if the shape is not same? Because currently we are considering 1D array, even if we have 3 elements over here, still it will be concatenated. Yes, over here we have 4 elements, over here we have 3 elements, still the concatenation is successful. So even if I write x as 0, the result is going to be same. Now, this was the simplest case for the 1D array. Let's understand how 2D array concatenation works. Now, considering the 2D array concatenation, first we have to define the arrays. Over here, I'm considering two 2D arrays, D1 and D2. D1 contains the elements 1, 2, 3, 4, 5, 6, and D2 contains the elements 7, 8, 9, 10, 11, and 12. All right. So these are the array elements that I have. Then, if I were to proceed with np.concatenate D1 and D2, if I don't pass an access, default access is 0. Let's see how are they concatenated. So because we do have the same shape, they can be concatenated vertically and they can be concatenated even horizontally. So if I'm passing x as 0 or considering the default access is 0, let's observe. So what has happened after 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 has been added below. All right. So when we are let's say utilizing column access or access is equal to 0, what is happening? New rows are created, right? New rows are created, but they are adjusted along the pre-existing columns. So no new columns are created, rather new rows are created. This is how we can interpret them. So if I'm passing it along axis 0, no new columns are created, rather new rows are created. All right, clearly we have seen this. So this was D1 and D2. Now what if I concatenate it along the axis 1? So this is my D1, D2. We have seen the impact of concatenating it along axis 0. Let's say no new columns are created, rather new rows are created, but along axis is equal to 1. no new rows will be created, rather new columns would be created. All right, so if you, okay, currently let me just get rid of this comment and even this comment. Let's stick to one particular comment that we can all follow, right? So in this example, no new columns are created, new rows are created. So likewise, this was for x is 0. But for x is 1, if you observe, no new rows are created, rather new columns are added. Right, so maybe I can mention new rows are added, no new columns are created. And over here, let's say new columns are added, no new rows are created. All right, so guys, if you observe this, this is what we have. See, after 1 2 3 4 5 6, what do we see over here? We have 7 8 9, and then we have 10 11 12. I hope this is clear to everyone. Now what if currently we have considered 2D array concatenation with the same shape? Currently the shape was same, right? Over here we have considered 2 3, and even over here we have considered the shape 2 3. Now what if we are applying 2D array concatenation with different shapes? So observe the first array, we have 2 3, and the second array, for the second array the shape is 4 comma 3. So if we have 2 comma 3 and 4 comma 3, now just think about the orientation along which they can be concatenated. Can we concatenate them along axis 0, or can we concatenate them along axis 1? So what is common in 2 3 and 4 3? 3 is common, right? What is 3? 3 is the number of columns. So the only option to concatenate them without disturbing the array property, without let's say actually violating the array building properties, is to concatenate them vertically, right, or along the columns. Means no new columns would be created, rather new rows will be created. So by default, the only way to concatenate them is to concatenate them along axis 0, right? So this is concatenation along axis 0. Axis is 0. Yes, so after 0 1 2 3 4 5, we are adding, let's say we are concatenating numbers from 12 to 23. So this was one example. Now what if ever I wish to concatenate the axis, the two arrays along axis 1 have bearing different shapes. So the first array, for the first array the shape is 5 comma 4, for the second array the shape is 5 comma 6. So if you observe the shape, what is common between these two? It is 5. So what does 5 indicates? 5 indicates over here we have 5 rows, and 5 indicates even over here we have 5 rows. So 4 columns are already present. Now along with 4, 6 more columns would be added. Alright, so no new rows will be created, rather new columns will be added. So if you observe this, till this part, right, till this part, this is what we have retained for C3, and the remaining part is C4, because we have concatenated it along the axis 1. So guys, this is how we have to deal with concatenate function. Moving forward, we have the vstack function. Now vstack function, they stack arrays vertically implying row wise. Alright, so one on top of the other. One row will be stacked on top of the other. So currently this is an example of vstack for 1D array. In the array n1, the elements are 1, 2, 3 and 7, and in the array n2, the elements are 4, 5, 6 and 8. For 1D array vstacking, we have to ensure that shape should be same for applying vstack on the 1D array, right? So when I'm printing n1 and n2, these are my two arrays, and if I apply np.vstack n1 n2, now I can write it like this. I can write it in a list, or I can write it in a tuple. Same goes for concatenate as well. It's not mandatory to write it in a list, even tuple would do. So n1 n2, see, they have been stacked vertically, right? So 1 2 3 7 and then followed by 4 5 6 8. What if the shape is mismatch? Suppose if I don't have an element over here, would we able to, let's say, stack it vertically? No, we are not in a position to stack them vertically, right? So if you observe this, this is not possible over here. Over here maybe I can write 9 and 8. So 1 2 3 7 4 5 9 and 8. All right, this is what we have. Now next, we can also proceed with vstack for the 2D array. So for 2D array over here, for array A the shape is 2 into 2. For array B the shape is this is 1 into 2, right? Let's print the shape. See, For array A, the shape is 1, 2, 2, 2. For array B, the shape is 2 into 2. So when I'm B stacking them, over here I've written A comma B. So it will be stacked vertically. So after 1, 2, 3, 4, 5, 6 is added. So this is how we are supposed to work with the V stack. Next we have H stack. So H stack, let's say it stacks the arrays horizontally, column wise, side by side. So this is an example of H stack for 1D array. All right, this is an example of H stack for the 1D array. Let's see how it works out. So this is 1D array. So of course, again over here, what if the shape is not same? Because we are stacking them, let's say horizontally, right? So even if I have one more element, it can still be added. All right, so for 1D array, shape need not be same as long as they are 1D array, right? For 1D array, for applying, what are we applying over here? We are applying H stack. Over here we are applying H stack. So over here we don't need to ensure that shape is same. All right, okay. Next, what if I apply H stack on the 2D array? So if I were to apply H stack on the 2D array, then what is the procedure? So this is np.array 1, 2, 3, 4, and then I'm printing A, and then np.array 5, 6, 7, 8, and then I'm printing B. So what is the shape currently? If I were to print A dot shape and B dot shape, right? So A dot shape and B dot shape, clearly the shape is 2, 2, and 2, 2, both sides. So if I were to stack them, A and B, if I were to stack them A and B, then what am I getting over here? Just observe this, because this is horizontal stack, right? This is horizontal stack, so this is kind of parallel stacking. So let's say no new rows are created, rather new columns are created. So after 1, 2, 3, 4, this part over here that we get to see over here, this is the A, and this 5, 6, 7, 8, this is the B part. All right, this part over here that we have, this is the B part. So guys, this is how we have to interpret and utilize, let's say, concatenate, VStack, and HStack. Moving forward, we have two more very interesting functions. They are insert and append. So as the name sounds, we do have the insert function even in list, and because let's say arrays are a level up to lists, so we are provided with insert function even for numpy arrays. So array में अगर हमें insert function use करना है, right? So insert simply inserts the value into an array at a specified index. जिस भी पोजीशन पे आपको insert करना है array में वो element, you have to mention it. Alright, so considering 1D array, this is 1, 2, 3. Now in the 1D array over here, I wish to insert in array A. Insert की property क्या है? Let's understand the function parameters. So it takes array, alright, then the object, and then the values. So object is basically the index. So I'm trying to insert, let's say, the value of 10 at index 1. Index 1 pe what was the previous element? It was 2. So prior to 2 I want to insert 10, because otherwise how would it be inserted at index 1? So clearly you can see that I've inserted element 10 at the index 1. Now in the second example, this is for 2D array. Alright, this is let's say insert with 1D array, right? This was an example of insert with 1D array. Now in the second example we have insert with 2D array. So I've considered two examples. Let's observe them one by one. So the array A over here is a 2D array with the shape 2 cross 2. Alright, what is the shape? The shape is 2 cross 2. Clearly we can see the elements are 1, 2, and then in the next row 3 and 4. Now what do I want to insert? I want to insert at index 1. At index 1, currently at index 1 we have 3, 4. So at index 1 I want to insert 10 and 20. So this is kind of inserting another row between some pre-existing rows. Alright, and what is the access that I've passed? The access is 0. So it simply means to insert row at index 0. What if there were more elements? Maybe we have 5, 6, maybe we have 7, 8. Still the logic works. Alright, please see. So 1, 2, 3, 4, 5, 6, 7, 8. I wish to insert 10, 20 at index 1. Now I could have inserted it at index 2 as well. Still it works. See. So after 1, 2, 3, 4, 10 and 20 are inserted. Alright, 10 and 20 are inserted at index 2. Now moving forward, over here I'm having np.array. 1 2 3 4 and 5 6, right? So currently how many elements do we have? We have 6 elements, and again this is a 2D array. So what is the shape? The shape that we have get to see over here is 2 comma 3. All right, the shape that we have over here is 2 comma 3. So next I'm printing array A. All right, and then np.insert over here we have array A, and then what is 1? 1 is the index at which I want to insert. Now what are the elements that I wish to insert? Because I'm inserting it, this, see over here I've inserted a long row, so this is inserting a row. All right, I'll mention it here, insert a row, correct? Now this is inserting a column. Let me copy this, insert a column. So how are we inserting it? Let's observe. So this is 10 20 30, right? So another column is inserted over here in between the pre-existing columns. All right, so this is insert column at index 1. So this is how we can work with the insert function. Just like insert function, we have append function. So what is the difference and what is the similarity? The difference is append adds the element or the rows or the columns at the end, whereas insert inserts rows or columns at a specified index. Now if I were to insert in 1D array, means this is an example of append in 1D array. So how do we check this? So this is a 1D array, right? We have A and B. We do have A and B. So I simply want to append 4 and 5 in 1, 2 and 3, and maybe 1, 2, 3, 10, 20, 40. So where do I add them? They are added at the end, right? So we have 4 and 5. Now what if let's say I were to add maybe 1, 2, 3, 4. All right, and after 1 2 3 4 over here I'm printing A, and then np.append A 5 6. So when I'm adding 5 6, right, so this would be added as the new row. So over here I'm appending a new row. So this is an example, I think, for 2D array. So this is append in 2D array. All right, so guys, over here we have added the elements. How have we added? Now we have added the element along the same column. So no new columns are created, rather a new row is added or appended at the end. So append will always add at the end only, right? Either at the rows end or at the columns end. See over here when I'm passing 4 5. So this was an example for 1D. So new rows are created, right, for 1D. Anyway, we don't need to call them rows or columns. But for 2D, in this particular example, new row is added, and in this particular example, new column is added. If you observe this, so currently the array's shape is 2 into 4, right? The current shape is 2 into 4. इसमें हमने जो elements append किए हैं, what are those elements? We have 11, then 12, then 13, and then 14. And I've added them along axis 1. Clear? So this is what I get. This is what I'm getting. So we have 11, 12, 13, and 14, right? So if you observe this, this is what I'm getting, and this is what we have. Now, moving forward, we have a couple of matrix related operations as far as NumPy is concerned. What are these operations? So we have matrix operations such as addition, subtraction, multiplication, division, the common ones. Then besides this, we have dot product, transpose, flatten, and trace. Let's understand the first four: addition, subtraction, multiplication, and division. And as the name sounds, addition is simply used to perform array addition, subtraction for array subtraction, and multiplication for array multiplication, and division for array division. So we can directly use array operators, right? We can directly use operators instead of using predefined functions. So what needs to be done? I can simply print, see, these are the two arrays and both are 2 cross 2. So because both are 2 cross 2, these operations we can perform. Okay, let's store them in some variables. So maybe let's call them q1. q1 is a plus b, and then q2 is a minus b. Then I'm printing q1, and then I'm printing q2. So this is what we have. All right, so see, added. So this is 1 plus 5 6, 2 plus 6 8, then 3 plus 7 10, and 4 plus 8 is 12. Now if we subtract, so a minus b, or let's do b minus a. So b minus a is, let's say, Okay, let me change a couple of numbers. Maybe this is 10 and what about, let's call this 8. So now this is what we have, 7 4 and 4 6. Likewise, this is addition and subtraction. So over here we can also go with multiplication and division. All right, so multiplication, A multiplied with B. So 1 into 8, these are the original arrays, right? Let me print the original ones. So we have A and B. Yes. So if you observe A into B, now over here we are getting 9, then 8, and then 10, and then 14, right? Okay, I need to print Q1, Q2 is done. So let's call this Q3 and Q4. Q3 and Q4. Yeah, just observe this. So currently it is performing element wise multiplication. 1 into 8 is 8, 2 into 6 is 12, 3 into 7 is 21, and 4 into 10 is 40. Now because I've implemented B by A, so 8 by 1, 6 by 2, 7 by 3, and 10 by 4. So this is how we can perform addition, subtraction, multiplication, and division. Next we have dot product, and then we have let's say multiply. So they are both used for matrix multiplication. Let's understand what matrix multiplication is, or let's first understand the transpose. So transpose is simply changing the rows to columns and columns to rows. Transpose simply means interchange rows and columns. All right. Using transpose, we can interchange the rows and the columns. So how to do this? Let's see this. This is the array, right? This is the array that we are considering for transpose. So how to apply this transpose operation? Maybe I can use r1.t, or the other option is np dot transpose r1. Now please observe the diagonal elements would remain same, otherwise the rows and columns would entirely be changed. So this is 2 8 14 4 10 16 6 12 18. And what about over here? Over here we have 2 8 14 4 10 16 and 6 12 18. All right, so this is how we can, let's say, apply the transpose. Next we have matrix multiplication. So let's understand the rule. Two arrays A with shape Mn and B with shape P into Q are matrix multiplicable if n is equal to P, and the shape of the resultant array would be M into Q. So let's see this with an example. Currently I've chosen two arrays with the same shape, 3 cross 3 and 3 cross 3, right? So when both arrays have the same shape, then how do we proceed for matrix multiplication? So there are two operations. I'll call them result one. The two functions perform the same operation, right? np dot dot, then over here I'll pass a1 and a2. This is first operation. I'll print r1. I'll tell you how are we getting these numbers. So the first row is multiplied with first column, and then they are added. So how we are getting 44, I'll just explain with one example. So it would be 8 into 3, all right, plus 5 into 4 plus 0 into 5. So 8 into 5 40, all right, and then 5 into 4, okay, just a minute, sorry, this is 8 into 3, right? This is 8 into 3 24 plus 5 into 4 20. So this becomes 44. All right, this is 44. Next, so 850 is multiplied with 716. So 8 with 7, 5 with 1, and 0 with 6. So what are we getting? 8 into 7 plus 5, and that is 61. All right, so this is how the first row is getting populated. So next 850 will be multiplied with 902. And once this first row is done, then for the second row, this 296 will be multiplied with 345, 296 with 716, and 296 with 902, and so on. So this is how the dot product or the matrix multiplication works. This is quite used in machine learning, all right, for linear algebra calculations. And then over here I can also implement this multiply. So even this will result into the same output. Okay, this np dot multiply, this is this is, I think, element wise multiplication. Yes, Over here we are getting the element wise multiplication, right? Please observe this, np dot multiply. So 8 into 3 24, 5 into 7, what are we getting with 5 into 7? 5 into 7 is 35, and then 0 into 9. So for 0 into 9 it's 0. Okay, I just need to change this, some minor change. If I'm using multiply function, so this is not matrix multiplication, this is element wise multiplication, right? We have just seen this is element wise multiplication. All right, so we are over here, this is returning element wise multiplication. So let's write it, this is element wise multiplication. And what about this? This is dot product, or this is purely matrix multiplication, the normal matrix multiplication that we have. So these are the differences between dot product and element wise multiplication. Next, we have a very important concept as far as NumPy is concerned, which is referred to as broadcasting. So when we are talking about broadcasting, so NumPy has a special feature called broadcasting that allows NumPy to perform element wise operations of arrays of different shapes and size, all right, without actually, let's say, replicating the data. So irrespective of the shape and size, let's say lower dimensional arrays can be broadcasted into larger dimension arrays as well. Let's consider this with an example. So b is only 10, right? So maybe I wish to broadcast this 10 into this array. So how this can be done? If I apply a plus b, so this was just a single number over here, this is a scalar value, but this is a array, right? So if you observe this a plus b, so this b is let's say broadcasted to the shape of a. I hope this is clear to everyone. So 10 plus 1 is 11, 10 plus 2 12, and then 10 plus 3 13. So this is with 1D array. All right, broadcasting with 1D array. Now we can also proceed with broadcasting with 2D array. Now again the same procedure followed, but for the 2D array. How? So A is NP array. This is let's say the shape over here is 3 1. Over here the shape is 3 only, right? So 10 20 10 20 plus 10 20 and 30. Over here we have 1 2 3. So now if I perform a plus b, just observe the impact. Just observe the impact. So what is happening? 10 is added to 1, all right, then 20 is added to 2, and then 30 is added to 3. All right, so if you observe the result, the arrays are broadcasted, right? So I hope this is clear to everyone. All right, so guys, that brings us to the end of this session. So let's switch to the PPT. So in this session, we have discussed, we have understood the functions to combine arrays. We have discussed how to apply the insert and append functions on the NumPy arrays, and we have understood its concept as well. We have also discussed how to utilize the matrix operation for arrays, and we have also discussed and understood the concept of broadcasting. Thank you.